So students, let us see this problem. The resistance in the following circuit are R1, R2, R3 is equal to 6 ohms of EM of the battery. R1, R1, R2, R3. When switch S is closed, this is the switch S, this when it is closed, the potential across the resistance R1, this is the R1, the potential across this R1 is changed by an amount is asking. This is Eamcet 2000 Eamcet 2020 problem. So you see this one, this is resistance R1, this is R2, this is R3, all are equal here. So this is 6 ohms, this one is 6 ohms, this one is 6 ohms is given. So this circuit is connected to 12 volts battery. When the switch is closed, what will happen? The current starts flowing from positive terminal to negative terminal. So current I is flowing in this direction. So how much current is I? You know Ohm's formula, V is equal to IR, that implies I is equal to V by R. So potential difference voltage we should know, and the resistance. Here the potential difference is 12 volts, V we know, but the R means this one is R, right? So the resultant of these three resistors, that is R, resultant resistance. So final resistance. Let us find out that resultant resistance. First of all, R1 and R2, these two are in parallel. Parallel means what can we say? The resultant resistance of these two parallel 6 by 2. 6 by 2 means so this is resultant resistance 6 into 6 by 6 plus 6. This is 6 by 2, right? 6 by 2 means 3 ohms. This is 3 ohms. This one is connected this R3 in series. So 6 plus 3 is 9. So the resultant resistance R is equal to 6 plus 3 is equal to 9 ohms here first. And the voltage V, the potential difference here 12 volts. So the current I is equal to V by R means 12 by R means 9. See this one 3 4 are 3 3 are, that is equal to 4 by 3 amperes current is flowing through in this circuit. So the current flows from positive terminals and flows in this direction through R3, and here the junction comes. Here the current I is divided in this direction, in this way and in this way. Since these two resistance are both are same, the current will divided in same parts. That means I by 2 in this direction and also in this direction, that is I by 2, right? So we can say that the current through R1 is equal to current through R1 is equal to I by 2, that is equal to 4 by 3 by 2, that is equal to 2 by 3 amps. Current is flows through this resistor R1. Here in this question, what is asked? The potential across the resistance R1. R1 potential is asking. So the potential V is equal to IR formula. Okay, I means the current through this R1, that is I by 2. I by 2 means 2 by 3 into R means R1 here 6, 3 2s are, so 2 2s are means 4 volts of potential difference across these two. So since he is asking in this 4 volts, so the option D is correct. If he asks across R2 will same, you will get 4 volts. If he asks across R3, then the resistance. So this part is 4 volts, and this part series connected. These two are V1 plus V2. That means this, let it be V plus 4 is equal to 12. So it will be 8 volts. Whenever it is 8 volts, it is 4 volts, then these sum of these two will be equal to 12 volts, then it is tallied. So it is not asking in this problem, but if it is asks, you should ready to do this also. So here the potential difference across the R1 is 4 volts. That is the answer. Thank you.